as Mark said, I'm a post-harvest entomologist. I was hired by USDA ARS, which is the research branch of USDA, back in 1997. So I've been there for more than 20 years at this point. I was hired as a post-harvest entomologist, meaning that I try to help farmers export their crops through the development of systems approaches, but also through the development of quarantine treatments, such as heat, cold, and irradiation, which I'll focus on today. Okay, just to give you some perspective on the amount of agricultural trade going on between the islands and the US mainland. These are numbers for Hawaii and Puerto Rico. We inspect in a typical year, this is from a few years ago, 80,000 shipments of agricultural commodities. So it's a huge effort with inspectors at various ports on our island in Puerto Rico. When something's detected, something like a quarantine pest, an insect that doesn't belong in the US, they typically will treat on site. That's typically a methyl bromide fumigation treatment. So there's agricultural trade by surface type shipments and also by air. Many of our commodities from Hawaii are shipped by air. More things that can handle a long shipment are shipped by surface, by sea. We also, of course, have huge numbers of passengers that travel between Puerto Rico and Hawaii and the US mainland, and we intercept products in passenger luggage. And you can see the numbers here. It's huge, almost 300,000. Agricultural products are found in baggage and carry-ons as well as check-in. And in those, we find 5,700 quarantine pests. That means pests that are unique to Hawaii and Puerto Rico that are not found on the US mainland. So potentially invasive pests. And due to this problem, we develop quarantine treatments for commodities that we know may harbor quarantine pests. That's my job. Just to give you a little background, the word quarantine comes from the Latin quadraginta, which means 40. And in the old days, hundreds and hundreds of years ago, when ships would come into port and it was suspected that they had a contagious disease, something like cholera or the plague, they would make them sit outside the port for 40 days before letting them in. And so now when we think of quarantine, we think of detention or isolation or exclusion. And of course, we're going through that now with the COVID-19 virus in sort of many different forms. So why do we have agricultural quarantines? So world trade, of course, is expanding every year. We're moving products, agricultural products, between more and more countries, farther and farther distances. And of course, there's the potential to move quarantine pests on those fresh commodities, especially. Quarantines are established to protect agriculture in the recipient country from these exotic pests, these pests that are potentially come from the source of the agricultural commodities. Okay, so the establishment of exotic pests, of course, can be very costly in terms of spraying your crop, damage to the crop, spraying the crop to protect it perhaps, and also in the terms of new quarantines that may be erected when a new pest arrives in a new area. So invasive species can be very costly. And indeed, Hawaii, we sit in the middle of the Pacific. We get a lot of tourist traffic. We get a lot of surface shipment type traffic. And of course, we have accumulated a number of serious quarantine pests, agricultural pests. A few are shown here. At the top, we have the melon fly. We have the, over here on the left, mango seed weevil, which came originally from India. We have this booger here. This is the lychee fruit moth, came from Australia. And then from South America, the white peach scale, which probably came out southeastern United States. So we're sort of a melting pot of pests. Because we have all these quarantine pests, Many countries want us to apply a quarantine treatment of some type, or to ensure that our commodities, if we're interested in exporting them, are free of any sort of problem pests. Okay, so quick overview of the talk. I'll first talk about quarantine insects, then talk about irradiation, the technology that we're using to export many of our commodities, then the commercial use of irradiation, both here in Hawaii and elsewhere. And then we'll discuss a little bit or show you some of the facilities we're using to irradiate product. I'll show a quick kind of home video of my own about the sweet potato production system and quarantine treatment and export system. And then some of the challenges we have in the use of irradiation. Okay, so back in the early 1900s, the Mediterranean fruit fly showed up in Hawaii, and since that time, Hawaii has had a federal quarantine, meaning soft fruits and vegetables from Hawaii cannot be exported to the US mainland and many other countries, but to the US mainland without ensuring that the commodity is free of pests. And in the case of fruit flies, that normally means that we're applying some type of a quarantine treatment. Historically, that has mainly been fumigation from a long time ago, or more recently, heat treatments, and then more recently, irradiation. And you see we also have additional fruit fly pests, which can be a problem. And most recently, just in the last year, we've discovered that we also have the olive fly, a fifth species of important tephritid fruit fly. Okay, so just a little background on what we also call phytosanitary insect pests, meaning that they, when they're on a plant, the plants are unclean. They're a phytosanitary pest. We use quarantine treatments to eliminate both regulated and non-regulated pests. And here I'll start drifting mostly into the area of irradiation. Our fruit flies, of course, the reason we have to apply a quarantine treatment is they're internal pests. We can't inspect for them easily. We see to the upper left here, the melon fly again. Next to that is the sweet potato weevil, which also spends its entire life cycle inside the sweet potato. We have also quarantine pests that are surface pests, such as the white peach scale, shown here on the lower left, on papaya, significant quarantine pest. We also have hitchhiker pests that can stop the shipment of commodities, such as ants. Ants aren't feeding directly on the commodity, but they can be found associated with the commodity and can be a problem. And then lastly, in the case of irradiation, sometimes growers or shippers will use it just as a form of insurance. So they have a commodity, let's say sweet basil, that they grow on Oahu and they want to ship to the US mainland. Well, it may have some kind of pests in there. And so they'll apply irradiation at a certain level, just as sort of an insurance policy. So if it arrives in California and an earwig crawls out or a leafhopper jumps out, they can say to California, we've treated it with irradiation, those insects will not reproduce. Okay, so getting into the area of irradiation. Food irradiation involves a number of different sort of applications. It's used to inhibit sprouting in plants and disinfestation in things like corn and rice and other sorts of cereals and grains. What we'll be talking about today is only its use in quarantine to help move fresh commodities. There are 3 approved irradiation sources. Gamma, typically that's from cobalt-60, which is a radioactive isotope. As it decays, it releases irradiation, and that irradiation can sterilize insects. 2 other types or sources are electron. First one is E-beam or electron beam, and the last one is X-ray, We have in Hawaii an X-ray irradiator on the bottom, and we also have an underground cobalt irradiator shown on top here. And we'll discuss that a little bit more in a bit. So the way irradiation works from any of these different sources is it breaks important chemical bonds within the insect and prevents it from developing normally. So typically it's a main target is DNA, breaks the DNA. So the insect doesn't die immediately, but because its DNA has been broken up and damaged, it won't develop properly and will not become an adult and will not reproduce normally. Okay, that's how it works. By comparison with other treatments, we like irradiation. People are more and more liking irradiation because it has many benefits. Other types of quarantine treatments that are used are, first of all, cold. Things like table grapes and kiwi fruit and citrus oftentimes they're all quite, have long shelf life. And so we can apply a cold treatment that can be anywhere from 2 weeks to 3 weeks long. Usually while we're shipping the commodity, we apply a cold temperature and control any quarantine pests. Heat is another type. Here in Hawaii, we use something called vapor heat to ship papayas to Japan, for example. The problem with cold is it takes a really long time. So if you have a perishable commodity, it doesn't work. Heat tends to, you're kind of cooking it. So you tend to have a quality reduction. Very common type of quarantine treatment is fumigation, in particular with methyl bromide. It's a toxic gas, potentially harms the environment, and there are worker safety issues as well, also potentially residues. Systems approaches, kind of following the theme of IPM, is a great sort of quarantine, we call it approach, a phytosanitary approach, but it's complicated, requires a lot of information about the insect and the crop and so forth. Takes many years to develop systems approaches typically. So the beauty of irradiation is it's simple, it's fast, it's safe. One of the shortcomings is retailers, the Walmarts and the Krogers of the world in the past have been reluctant to carry irradiated product, but we'll discuss that. Okay, so irradiation.
Peter, we
Yes,
have a quick question, if I may, from Sage. She asks, are the fruits just sitting in a cold room or hot, warm area for a certain amount of time? Or how does that work? Hot room. So the fruits sitting in a cold or hot room. Yep.
Right, so it can kind of, it differs depending on what the commodity is and where it's going and how much of it's going. So in the case of citrus, if South Africa is sending oranges to Europe, for example, it's on a big ship. The fruit are in bins in a large hold, and the whole large hold is kept at a low temperature. In other cases, it may be, the cold treatment may be administered in a 40-foot shipping container that's on a larger boat. So cold can kind of vary. Heat treatments are typically done in a heat treatment facility. In large bins, they're put into a big heat chamber. They bring that heat up for a period of time, then drop it again, cool the fruit off, and then ship it. Okay, so depends a little bit on the fruit and how much you're trying to treat, I suppose. But yeah, good question, Sage. Okay, in the case of irradiation, again, let me just preface this by saying Hawaii uses irradiation more than any other quarantine treatment. So many of our commodities are shipped with irradiation. It's the only way to export our commodities, the only approved quarantine treatment. So I've focused a lot of my research effort over the last 20 years on irradiation. So the beauty of it is it's effective against everything, all kinds of insects, mites, other types of organisms. The real beauty of it is that most products, there are a couple exceptions, most fresh fruit, for example, tolerate it really well. At the low doses we use to control insects, it's way below any sort of damage to the commodities. So that's one of the beauties of irradiation. In some cases, it can extend the shelf life. The cost is competitive. It's fast. It's a matter of minutes to treat a box of fruit, for example. You can treat in the final packaging, which is an advantage. Whether it's gamma irradiation or X-rays, it penetrates any kind of packaging to hit the insect inside the fruit. You can treat at any temperature, which is not true of many types of fumigants. No resistance has ever been shown to irradiation. The damage is so massive and it's so integral to the development of the insect that there isn't really any sort of resistance mechanism. You do get live pests, meaning you irradiate something, it doesn't kill it immediately, like the other sorts of treatments do, but that's not a problem. They will eventually die and they will be sterile. And the real beauty, which we'll talk a little bit about, is generic treatments. There are treatments that have been approved to cover all insects. So we don't need to develop individual treatments for insects and specific commodities, which is a huge advantage. And here are those generic treatments. So the FDA many years ago approved irradiation up to doses of 1,000 grays. That's the unit that we use to measure irradiation. So that was approved way back in 1986, but not used for a long time. More recently, in 2006, we approved, or APHIS, USDA APHIS approved, 2 generic doses. First, for taphritid fruit flies, which are sort of the most important quarantine pest worldwide, 150 grays. And then a higher dose, 400 grays, for almost all other insects that occur on fruit, with the exception of Lepidoptera pupae in adults, which may sometimes require a little bit higher dose. And then we also have specific doses for many important quarantine pests, like codling moth and oriental fruit moth, and many different pests, quarantine pests in the US. We have quite a lot of information, and we actually have specific doses for those pests. Okay, but these generic doses are the real key to why phytosanitary irradiation has become so popular. Really, that rule came through in 2006, and in 2007, countries started flooding the US with requests to use irradiation to export fruit to the US. Most of those countries wanted to move mangoes to the US because mangoes are so commonly grown in Asian countries, and they all wanted to send mangoes to the US. So you can see, though, here's an example. The US does not use irradiation to export, but it is receiving a lot of imports from using irradiation from different countries. And you can see the countries listed here. And what I really wanted to point out is that the volume is increasing every year, as shown in the graph, but also that we're using these generic doses, meaning all they had to do was apply to USDA APHIS. APHIS did a pest risk assessment, found all the pests that are on there, and then gave them this approval with a generic dose. So we didn't have to develop specific doses for each pest found on the commodity. Likewise, in Australia, they've picked up on it in recent times over the last 10 years. They're using it domestically to move fruits to areas where they have a quarantine, where they do not have a quarantine pest, from areas where they do have a quarantine pest. They're shipping fruits to New Zealand, which is amazing because New Zealand is a what do you call it? A radiation-free zone, but they're welcoming these products from Australia. And then these other countries as well, mostly in Asia. But again, look, they're primarily using these generic doses. In Hawaii, we have approvals to export using irradiation 26 something different fruits and vegetables. The primary ones that we're exporting are shown in red. You can see a number of fruits there. Our biggest export actually is sweet potatoes at this point. We're X-ray irradiating, but also cobalt now, irradiating to export roughly 10 to 15 million pounds of sweet potato, which is our largest export.
Question there, if I can interrupt you quickly. Yeah. Kenneth asking, what's the difference between graze and sievert for radiation treatments? I guess sievert is another measure.
Yeah, so good question. There are simple formulas for converting different units of irradiation. Sieverts is not used as much as now as it was 20 years ago. We also see in the literature the use of rads. We also see the use of Roentgens. They all are measures of units, measures of radiation dose, and they can be converted easily between each other. When we talk about X-ray doses at the doctor, for example, we talk about rads. And the reason we use rads is it's kind of 2 log levels below these grays that we use for insects. So it's just a matter of convenience. You tend to see different units used in different fields, but it's all the same dose, just described using different units, which can be converted easily amongst themselves. Okay. Okay, just to show you Hawaii's 2 commercial irradiators. The first one began operation in 2000. It was called CW Hawaii Pride at the time. It's now called Calavo Growers. It's an X-ray irradiator, so it uses electronic source of radiation. The facility was designed to treat fresh produce, originally papayas, although now it mainly treats sweet potatoes. But it treats a variety of other tropical fruits too: longan, rambutan, lychee, mangoes, dragon fruit, and so forth. The downside of building a facility like this was the first of its kind in the world. It was very expensive. It cost about $12 million. Okay, a second facility was built just about 6 or 7 years ago. It's located on your island up in Kunia. It's called Paina, Hawaii. It uses an underground cobalt source, so a radioactive isotope, and you can see the picture on the lower right. You can see the radiation emitted by these cobalt rods that are reacting with the water and giving this sort of blue color. It also was designed, this facility was designed to treat fresh produce. And it was relatively inexpensive, roughly $3 million. Okay, both are still in operation. Both are still irradiating produce from Hawaii for export mainly to the US mainland. Here's just a picture of the Calavo, the Hawaii Pride, the X-ray facility over here in Hawaii, Hawaii Island. They've dropped all of the concrete shielding that surrounds the conveyor system so that we can see the conveyor system. And I'll show you a short video of that later on. But just to give you an idea, so product is loaded into boxes, carried on sort of this carrier system like a ski lift in front of the X-ray beam, and then goes out afterwards, treated, and then can be exported. Okay, first pop quiz. Everyone still there? Let me look. I'm looking at the number of participants.
Yes, sir.
Pop quiz. Godzilla's energy beam is aimed at a giant insect from what order? Come on, come on. You're going to have to take the mute off.
Lepidoptera.
Quick, come back to
Lepidoptera.
the computer. I hear Lepidoptera. Anyone disagree with that?
Hey.
Lepidoptera. Good identification. Does anyone know the name of the movie?
In that movie that has the, I don't know the name, but I know it's one old guy now. has like big, huge worms from underneath the soil that don't have eyes, but they have hearing senses. What was it?
Well, that
Tremors.
That's tremors.
yeah, there are many Godzilla movies and many foe that have been brought in by different people to try and defeat Godzilla. This is an old one from the early 60s called Mothra. Godzilla versus Mothra. And Mothra, of course, developed as a large caterpillar before becoming Mothra. And the Japanese used Mothra to try and defeat Godzilla. Good. Good taxonomic skills in the class. Okay, here's where things get kind of tricky. I'm going to show you a short video. It's a homemade video, something I did with a video camera. It's a silent movie, so I'll sort of talk you through it. But basically, it shows you sweet potato production and then all the steps that occur on the way up to getting irradiated and exported. So I'm going to take just a second to escape from this slideshow and then bring up this video if I can find it. There it is. Okay, so I don't want to take any chances here to full screen it. So let's just look at the video on a slightly smaller screen, if that's okay. Okay, ready? Set, go. Okay, as I said, sweet potatoes is the biggest export of fresh produce from Hawaii, mainly goes to the US mainland. This is a field of sweet potatoes.
Sorry to interrupt, but I don't know that we're seeing the video. It's not coming over on my side. I'm not sure if anyone else.
Same
I think you
here.
need to bring it to the front.
Okay, hold
Yeah, I
on
don't
just
see the
Slide
video.
down the
a
PowerPoint a bit,
second.
like we did yesterday.
Okay, so I'm doing stop share.
Oh God.
Okay, now I'm going to do start share again.
Okay, good luck.
And now
Sure.
I'm going to the video. Do we see
Okay.
it?
Yes.
Yeah, okay, my apologies. Sorry
No
about
worries.
that. Okay, let's start over. Oh, that doesn't look good. Pardon me. Okay, ready, set, go. Okay, so this is a sweet potato field on the Big Island. Many of our sweet potato growers are Chinese nationals or background. This particular person is Sang Lam, he's Vietnamese. At the time, one of the bigger sweet potato growers. He's showing us a root that he pulled out of the field. Now that root is host to a number of quarantine pests. This one is called the sweet potato weevil. It's a pest that's common in the southeastern United States. Very beautiful beetle with the snout that permanently facing forward. It's metallic blue and red. All the growers know about this pest. It's very easy to see when you harvest sweet potatoes. And when you leave sweet potatoes in the field, you can pick up a sweet potato and see this weevil very easily. It's a quarantine pest for California. There's another weevil that's found on Hawaii's sweet potatoes. It's called the West Indian sweet potato weevil. Our growers had no idea this insect existed. It's small, it's kind of looks like a speck of dirt. You see it here in the middle of the screen starting to move. And you can see why the growers really had never recognized this pest at all. The other weevil, very easy to see. This one, hard to see. Okay, both quarantine pests. A third pest, the sweet potato vine borer, mainly a vine pest, but can occasionally get into the root. So the big problem early on with growers is basically they would grow sweet potatoes until the pest problems got so bad. And then, like they do with ginger, they would abandon the field and go plow a new field, okay? And the reason the numbers got so high is they didn't practice sanitation. All these roots that are left in the field are a nursery for huge numbers of the pests, mainly the sweet potato weevil and the West Indian sweet potato weevil. So we now have them doing a better job of sanitation, removing those old roots. So those roots are brought into a storage shed. They're cured for from 7 to 10 days, ideally, in the boxes, oftentimes as they are here. You can see that the roots are many different shapes and sizes. We kind of need a breeding program here to try and make those more uniform. But that's how we grow purple sweet potatoes. Insects are a serious pest problem and probably the major problem that growers face. So those boxes were closed up, put on a truck, and then the truck is brought over to the irradiation facility, offloaded by the pallet, shown here. And then brought to, this is just the front door of the irradiation facility. You can see all the cement to the right. That's where the irradiation happens. They have 12 feet of cement between the X-ray irradiator and the outside, so that no X-rays escape the facility. The new owner is Calavo Growers, a California-based operation. The person facing us here is Eric Weinert. He was one of the founders of this irradiation facility. He was originally a tropical fruit grower who wanted a way to export rambutan and longan and other tropical fruits, and he founded this facility. So you can see product outside waiting to come in. Couple different brands of sweet potatoes from different growers. This facility, less so now, but years ago, this facility also irradiated product that was shipped over from Oahu. This is before we had an irradiation facility up in Kunia. In this case, I think that's curry leaf, which is something we export with irradiation. So it arrives, it gets inspected. The inspectors will open a certain number of boxes from each pallet. They'll pull fruit out, they'll look at it, they'll see if they see obvious signs of insect damage. This is occurring at the irradiation facility. With some commodities, this type of inspection goes on at the packing house. But here in Hawaii, we do it at the quarantine treatment facility. So he saw some little feeding damage on here. When the roots are exposed, when they're outside above the soil a little bit, you'll get some weevil feeding, those little dark spots that you see on the skin here. So he's cutting the sweet potato, looking to see if it's badly infested. The irradiation treatment will control the pests, but if there's a phytosanitary problem, if the commodity is heavily infested, they'll reject it. Now, in the case of longan, which they're inspecting here, the main problem with longan is not an internal pest at all, it's ants. So he's flipping over these bags because he knows from past experience that oftentimes they'll have ants. If he finds ants, he may return it to the grower to get them cleaned up. Here's another example of an inspection. In this case, this is Hawaii grown curry leaf. Curry leaf is grown on your island. At the time, they were shipping it over here to the Big Island for irradiation. Now it's all being irradiated up in Kunia. This is a tough one to inspect. What's he looking for? We have no idea. But if something flew out or ran out or jumped out, he would start to inspect more closely. But you see with a 20-pound box of curry leaf, there's a ton of leaves in there. He's not really looking for every last possible insect. He's just looking to see if it generally has been produced in using good agricultural practices. He fills out a form, says that it's certified, ready to go. At the irradiation facility, these are the loaders, the people that load the boxes onto the carriers. In this case, these are sweet potatoes. Those are 30-pound boxes. So pretty heavy box, large box. And you can see some of the boxes are kind of collapsing under their own weight. This is the carrier. You can see them moving into the irradiation chamber. So they go through a labyrinth and they get treated and then they come out the other side. It's all computer controlled. They know where the boxes are at any time. Here's kind of a simulation of what's going on. That's the X-ray system treating boxes of whatever commodity on these carriers. Okay. So this is a LINAC, a linear accelerator, firing electrons into a metal target, which releases X-rays on the other side. So everything's treated with X-rays. This is what the actual linear accelerator looks like, LINAC. Okay, so the sort of crux of the whole process is we have to be able to measure the dose accurately. And we do that with something called a dosimeter. This is called an optichromic dosimeter. It's what we use here at the X-ray facility. That little tiny pencil there has a liquid inside it. That liquid changes color when it's irradiated. It turns blue. That little reader measures the change in blue color and associates that change with a dose. You can see the dosimeter goes in this little holder and gets put with the commodity as it gets sent through. Okay, after we've irradiated it, it comes out the other side, and you see this person with a roller putting on, rolling on a stamp which says that it's been irradiated. So in Hawaii, the inspectors have faith that we've applied the process properly, and they really just look at the paperwork to show that the right dose has been applied. And they trust the facility enough to give them this treated stamp. And you can see they roll that stamp on so that it will be approved when it arrives in California. We also have a little sticker here on all boxes that says who the grower was, what the date was, and so forth, so we have traceability. Okay, after it's been treated, we repalletize the boxes. In this case, the boxes of sweet potatoes have been shrink wrapped, and we put them on into a container, in this case, a refrigerated container. Is that going to fit? And that Matson container is shipped back to Oahu, put on a large carrier container, this one, and shipped to the US mainland where it will be broken down and distributed to grocery stores. So the trip takes between 7 and 10 days. Obviously, surface shipment only works with a very a commodity that has a long shelf life, like sweet potatoes. Many of our perishable commodities, many of the tropical fruits are actually shipped by air. Okay, so I'm going to stop sharing that and hopefully we will get the PowerPoint presentation back with a little work. Excuse me just a second while I look for the PowerPoint. Yes, it's still there. Mark, we did it, or I did it. You did it. You showed me how to do it.
Well, you kept it together. I'm impressed.
Okay.
I think you're going to have to hit screen share again because we're not seeing the presentation.
Okay, sorry about that.
Try screen share again. It didn't.
Yep, I'm on the wrong spot here. Hold on just a sec. I'm sure there's an easier way to do it, but I'm not doing the easiest way. Okay, screen share. Here's the talk.
Cool, coming up, good.
Talk, we're cue it back up. Okay, a little bit now on sort of the type of research we do to support the industry and support these irradiation facilities. Just got a handful more slides. We good?
Yep, perfect. Yep.
Okay. So much of our research now focuses on lowering the dose for pest. As I mentioned earlier, the FDA has approved a maximum of 1,000 grays. So when we treat something at an irradiation facility, to apply the irradiation dose to the interior, the middle of the load of fruit, we overdose the outside. And because we have that 1,000 gray ceiling, we have to be sure that the dose uniformity when we apply the irradiation does not exceed that 1,000 grays. Remember now that one of our most used generic doses is 400 grays. Well, in Hawaii, most of our commodities have a max min when we treat it of 1.5 to 2. So if we treat at 400 grays, usually they shoot a little bit high, let's say 450, and they have a maximum twice that, they're still at 900 grays, well below the 1,000 grays. But with some of the larger irradiation facilities around the world that are applying this treatment, we get a higher max min, something up closer to 3. So if we can lower the dose for a particular commodity below 400 grays, it'll be safer. We won't exceed that 1,000 grays. So we lower the dose to avoid the limit, the 1 kilogray, 1,000 grays. It also, of course, is cheaper. You can push product through faster if you're treating it at a lower dose. And if there's any potential quality problems at higher doses, you can avoid that by lowering the dose. So a lot of my work actually has been towards lowering doses for different pests below that 400 gray generic dose for all insects. And to do that, the general methods are shown here. In this case, we're putting fruit flies inside a papaya, but we've done the same thing with weevils inside sweet potatoes and really a wide variety of pests and commodities. So in the case of papayas, we drill a hole to the center. We put 50 to 100 fruit fly larvae into the center. We seal it up, and then we put it on the carrier and treat it. And typically when we do this, we'll treat at a series of doses, increasing serial range of doses of irradiation. We'll also treat all the different life stages separately. And then we'll identify the most tolerant life stage and a prospective dose, and then try and treat a large number of insects at that dose. Okay, so that's the general methodology for developing a quarantine treatment. And we've developed treatments for a wide variety of insects. 3 of our main fruit flies, those 3 sweet potato pests that I showed you, 150 grays. The mango seed weevil was my first project. We developed a treatment for 300 grays. Lychee fruit moths, a couple scales, a banana moth, 4 species of ants, and so forth. In total, about 30 different insects that we've developed radiation tolerance information for. Okay, just as an example, most of the ones I showed there a second ago were pests found in Hawaii. Spotted wing drosophila, we have it in Hawaii, but it's not a pest here. But it was introduced to the mainland US maybe a little more than 10 years ago, and became a serious pest, particularly on small fruits and stone fruits. California, it's one of the major pests there, okay? But we had it here in Hawaii, so we developed a colony and developed an irradiation treatment for it. This pest has spread across the United States now. It's spread across most of Europe, but it's still not found in Australia, New Zealand, and parts of Mexico that receive a number of our fruits. So irradiation is a possible treatment to use to control spotted wing Drosophila in commodities exported from the United States. So we found out that the pupa was the most tolerant stage, and we treated a large number of pupae at 80 grays, quite a low dose, to show that it was effective. Same sort of process for coffee berry borer. Again, discovered about 10 years ago in Hawaii. It's on the Big Island, it's on Oahu and Maui now, but not on Kauai. And so when we move green coffee beans around the islands, it requires a quarantine treatment. Typically, that's a fumigation treatment. We wanted to see if we could treat it with irradiation. The adult was the most tolerant stage. We treated about almost 7,000 adults in coffee at 100 grays and sterilized them. So potentially that's a quarantine dose for that pest. That's the type of work we do. Okay, so pop quiz. Everyone ready? Uh-oh, wake up out there. Okay, what are the 3 benefits of lowering irradiation doses? You're gonna have to unmute if you want the world to know your answer. Anyone game?
Was it less cost?
Cost, yes, cost less. If you can treat something at half, at a dose that's half 400 grays, it takes half as long to treat it. So it costs roughly half as much. Yeah, good. Okay, let me just put up the others. In some cases, we have quality problems. Like I said, most of our fruits in Hawaii do really well. Avocado is an example of a fruit that cannot tolerate irradiation. No matter how low the dose, it causes the flesh to turn black, kind of streaky and black. So potentially you want to lower the dose to maintain quality. It's always cheaper to treat something faster, and to treat something faster, we treat at a lower dose. And of course, if we can treat at a lower dose, if we can treat at 200 grays instead of 400, half the cost, and you can treat twice as much. So that's why we try to lower the dose. Okay, just the last few slides. There's a couple regulatory issues here. So as I said, Hawaii is using irradiation to export, to treat fruit to export to the US mainland. The US will not use irradiation. None of the fruit industries in the US are totally on board to use irradiation for the simple reason that we don't have country approvals. Japan, Canada, Taiwan, South Korea, the European Union, those are our biggest fruit export destinations. And in all those cases, the countries have not approved phytosanitary uses of irradiation yet. Many of them use irradiation for other purposes, but not for fresh produce. So until that changes, the US will never use irradiation in a big way. Another problem, labeling. Very early on in the approval of irradiation as a technology, they declared it an additive rather than a process. Because it's called an additive in regulatory language, it has to be labeled. And so we have to have this labeling requirement for all irradiated product. It has to have this Redura symbol shown up at the top here, and it has to say treated by irradiation. I don't mind labeling product, but to me, if you're going to label it, tell us why. Treated by X-rays to protect US agriculture. Rather than sounding like a warning the way it is, let's make it informative. The last sort of problem is they've restricted the use of modified atmospheres. When we want to ship produce long distances, we need to ship it cold to make it last longer, to improve shelf life. We need to control moisture loss. And in some cases with highly perishable commodities like sweet cherries or strawberries or raspberries, we want to apply modified atmosphere, which means lowering the oxygen concentration to improving shelf life. Anyway, that's currently restricted. We're doing a lot of studies right now to see if that's necessary. Fruit quality are sort of the technical challenges now. We need to be sure with all these treatments, any kind of quarantine treatment, that fruit quality is maintained. And also there's some area possibly for some new equipment. And I'll just mention some work we're doing in that area. Okay, first just a quick fruit quality study we're doing in New Zealand. New Zealand is very interested in the use of X-ray radiation to export apples. They don't have X-ray equipment in New Zealand, so they've shipped us several of their varieties so that we can treat them and watch their quality after different periods of storage, different storage duration. So all of the short of the story is all of their apple varieties tolerated irradiation very well, except Gala, Royal Gala. At higher doses, shown here in this figure, at 800 grays, we saw this sort of internal browning. So that's potentially a red flag. So why do we want to lower the dose? If the pests in New Zealand are controlled down here at 150 grays, and we know we have a twofold max min value, that means a maximum of maybe 300 grays. That's nowhere near where we start to see this damage to Royal Gala. So if we can control their pests at lower doses, no quality problem. If we have to use that 400 gray generic dose, wow, suddenly some of these fruit may be up in this area where we see damage to them. So lowering the dose for the pest of concern in New Zealand is a big priority now, so we don't run into this quality issue with Gala, which actually is their #1 export variety. Another project, last few slides, another project we're interested in is, you know, not everyone wants to go in full scale with a gigantic concrete standalone irradiation facility. So we were interested in this, seeing whether we could develop a small portable X-ray irradiator. And here was sort of the original design, looked something like this. We've actually started building this, this system shown here inside a 20-foot container. And you can see the different elements of it here. This is the irradiation box in here. That's covered with lead. These are the irradiation tubes, these things right here. And we've started doing simulations. This is a simulation using boxes of cherries. The idea is that the box of cherry is on a conveyor. It goes, this is the X-ray tube here. It's releasing X-rays in all directions, 360 degrees. So we pass the box over the top, shown here, and then it drops down and we pass it underneath the X-ray tube here. And it's a way of applying X-rays to the fruit to control any quarantine important insects inside. Anyway, we're still developing this technology. A lot of smaller industries that don't have high volume, high throughput, are very interested in this machine if we can ever get it, the kinks worked out. Okay, so we've mostly talked about insect pests. Last slide here just to show you that there are other pests that are super important and of concern to our export partners. This one, of course, is the, I don't know if you guys worry about it there. We worry about it every day here on the Big Island. This is Parmarian martensii. It's the primary semi-slug host of rat lungworm nematode. These slugs crawl into boxes and get onto produce. They've been found on sweet potatoes and taro leaf that we've exported to California. Of course, they're a little concerned about the slug because it's not found in California, but they're really concerned about the human pathogenic nematode that's found inside. So we've started doing some research with this slug. So far, we're rearing the slug. We've treated the slug with irradiation. We know we have a dose to control the slug to prevent reproduction. We have to do tests by irradiating the slug, irradiating the nematodes, and putting them inside an alternate host, the rat, to see whether we can also control the nematode. And that's the piece of research that we're doing in cooperation with the School of Pharmacy here, Dr. Sue Jarvie. Okay, that's all I have. Any questions?
You're still doing that? You still jump off mountains?
Pardon me?
Are you still jumping off mountains?
No. I gave this talk in Korea, and my first paraglider, my first wing was a Jin glider. It's made in Korea, in South Korea.
Ah, cool.
The good old days.
Aye.
No, I told you I crashed once, and my daughter told me to stop, so I stopped.
Oh, right. I forgot about that. Okay, cool. Interesting, Peter. That's some amazing stuff there. I had one question. So you get a much lower dose for, say, for CBB than you do for a Lepidopteran pupa. Is that because of body size, or is there some other physiological defense that leps have?
You know, the radiation tolerance does seem to differ broadly by insect order. The toughest insects to control so far are Lepidoptera. Flies and beetles just generally tend to be easier to control. It's not a function of size, just something about Lepidoptera. There are some theories about it. It has to do with how the chromosomes are set, the physical layout of the chromosomes in Lepidoptera. They have many centromeres. So if they're damaged, they still go through mitosis and meiosis properly.
Oh, wow.
Compared to other insects. So it's not well understood, but there's definitely taxonomic sorts of differences in susceptibility. Yeah.
Okay, cool. Thank you. Anyone else? Any questions that anyone has for Peter while we have him here?
I have one question.
Go ahead.
Besides the labeling products and the public pushbacks for irradiated produce, is there other like public pushbacks in regards to this kind of technology?
Say that again, pardon me?
Are there other public pushbacks for irradiated produce besides like the labeling issues and all that? Like, is there?
Like public perception?
Yeah.
Yeah. So, I mean, that's what you hear, no matter who you talk to, when you bring up irradiation, they say, oh, the consumers won't buy it. Well, the experience so far with a number of countries, and again, really we've been exporting irradiated produce to a number of different countries, you know, between a number of different countries, just in the last 15 years. When irradiated product is put on the shelves, consumers buy it, and they buy it again. They purchase and repurchase, especially if there's an education program that accompanies the rollout. And typically stores are doing that. They educate the consumer as to the benefits of irradiation and let them taste the fruit. And as I said, because it doesn't change the temperature of the fruit when you irradiate it, the fruit tend to just taste better compared to other types of quarantine treatments, such as cold or heat and so forth. So, you know, the quality is very high. The consumers, if the price is good, they seem to buy it. So that is the fear, and I think that's the fear, especially in retailers. For example, Walmart made a boardroom decision about a dozen years ago that they were not going to carry irradiated product. But when Mexico got approval to export guava into the US, the only way that they could export guava to the US was with irradiation. Instantly, Walmart was carrying irradiated guava. It was such a big, potentially a large market for the Latino population in the US that they instantly carried it, and they with all the labels and everything, and didn't even blink an eye. So again, never been any sort of protest or public backlash or anything like that since. So experience is that the consumers will buy it, and that there isn't strong opposition. Whole Foods, and there's always going to be a segment of the population that will not eat irradiated product. Whole Foods will never carry irradiated product. But it is being successfully marketed in many countries at this point.
Okay, excellent. Thank you, Peter.
I have a question, Dr. Follett.
Go ahead.
Can you hear me? Oh, I'm sorry, this is Brian. I just wanted to ask what makes avocado so special that that the flesh rots from being irradiated?
Yeah, you know, I don't really know. Someone had told me a long time ago it's because of the high oil content in avocados. When you irradiate something, it tends to oxidize the substance, whatever the target, and possibly these oils oxidize and turn dark. But then when I met one of the world's authorities on avocado quality, and I said that, and he said, "That's baloney." So my information may be bad, but of the fruits that we've tested, and we've tested maybe a dozen, 15 fruits here grown in Hawaii, only avocado shows that kind of damage at very low doses. So not sure why, possibly due to the oil content.
All right. Okay, any other questions? We're kind of getting close to the end, and I think as much as Zoom is going to allow me to record pretty damn soon. Anyway, thank you so much, Peter. If we were in a classroom, I'm sure everyone would give you a round of applause. But I know everyone, here we go.
Thanks for sticking with
Good
me
job.
for so long.
Yeah, and thanks to Patrick, Kai, and Kenneth for appearing on camera. It made our day. Brian sent some hand claps there. Very good. Okay, guys. Okay, everyone. Thank you again, Peter. Very much appreciated.